Did you bring the one you wrote? Just to show us the graphs. Your thesis.
I'll bring it. All right, so just just to summarize what I've done, typed in the data, selected the data, went to insert, clicked this kind of graph, all right, and then spruced up the graph from there to input a trend line or input an axis label or axis label here. You click in the graph. You go to chart tools and design. You go to add chart element. From this menu, you can go to axis title, primary or vertical or horizontal, and that lets you add axis titles. Or if you want to add a trend line, okay, you can pick linear. Or what I did was I went to more trend line options to add not only the trend line itself, but to also forecast backwards or forwards, and also clicked on these to give me the equation and the R squared. All right. So that's how I inputted the axes labels. For the tick marks, I right-clicked on an actual axis, went to Format Axis, and did all that here, as well as tick marks, and as well as number, if I want to adjust the number, the decimal place, if I want. All right, so that's how I did all that, just to summarize. Any questions so far? One more thing I want to show you. Why is it important to have axes labels? And to know what the data is. I mean, numbers are great, but if there's no units attached to them, who knows what you're looking at? In this case, what does the slope represent? Do you have any clue? What are the units of the slope here? What is the slope? Defined as the rise over the run, and it's the density in this case, right? So the rise is the mass, and the run is the volume. So grams over volume, grams per milliliter would be the units of the slope. It represents the density of the solution. Next week, we're going to do a graph just like this, and you're going to figure out the density of solutions from the graph. Okay. There's some other jargon that you might not be aware of. They call the y-axis values, they call that the dependent variable, because it depends on the x inputs. Okay, so the x values are the independent variables. So y dependent on the x values, which are the independent variables. Oh yeah, so one more thing I wanted to show you. What if we had another solution? Want to see something cool? Okay, I can type in mass and gram again, or looking at this box, I can move my cursor and you see what happens? When I move my cursor in this little corner box on the lower right-hand corner, you see that? You see what's happening? If I just left click that and then drag it over, I get the same thing. All right. What if I measure the mass again, but I get a different set of masses? Same volume that I'm using, but I'm just going to make up some numbers. What if it's just picking some numbers, I'm just making something up. Alright, so, again, I can add a bottom border on these two. So I just clicked on, I can add borders here. So what if I want to include this extra set of data in the same graph? Alright, well, let's do that. So I'm going to click in the graph again. I'm going to go to Design. I'm going to go to Select Data. And I have Series 1 here. I'm going to add a second series to this. And the X values are going to be the same volume. And the Y values are going to be my new masses. Alright, and the series name I can pick actually from this. I can pick this column. And click OK and just click OK. Alright, and notice how I have a second set of data on the same graph. So as long as I'm in the graph, I can go to Select Data and do that whole thing. And then you can go through the same process. You can right-click on that data, add a trend line, display the R squared and the equation, forecast it backwards or forwards. Why not forecast it 5 forward, 4 back? And here's the second equation. And I'm going to go ahead and enlarge that a bit too. Actually, I'm going to go ahead and shrink this font a bit because I'm going to have to put in something else too. Again, if I don't like the dotted line, I can go ahead and just format the trend line by right-clicking on it and go to this paint icon and make it a straight line. So, okay, 2 questions for you. Which solution is which? Can you tell just by how I place the data here? I actually have three questions for you. Alright, just to make things look nice here, I'll make these. Okay, so which solution has the greatest density? Solution 1 or solution 2? Yeah, solution 1 clearly has the higher slope, right? So it's got the greatest density. What might be a better way to label these? So let's see, we can add in something called a legend. Alright, again, I can go to Design, Add Chart Element, Legend. And it gives me an option here of right, top, left, bottom. You see how it just kind of moves around depending on where I want it. I'm going to put it on the top. Just because it seems like I got more room there. There's more legend options here as well. Let's see. I'll pick top. kind of gave me some weird things here. Well, let's double check what this is really doing. So yeah, it says series 1, but then it says mass of gram solution 2. Let's go ahead and go back to data, select data, and format this series 1. And if I go to series name, I'm going to select this cell. See, now it changed the name because now I told the cell I want to label.
Wait, can you go back on that one? Right back.
And so go to,
I'll look at it for you. I just want to know.
and go to select data, and you click on whichever one you want to change the name of. And go to edit, and you click on this series name, and you click on the what it wants. I don't know why I did this, but it kind of left this linear graph right here with the dotted line, even though it's not in the graph anymore. But it does let me click on it and delete it, so I'm just going to delete it. Now I'm showing you like how to make it look like, you know, super spruced up. When you make a graph that looks super neat, it screams, believe me, I know what I'm doing. Believe my data. I could be lying to you through my teeth, but you're going to believe what I'm saying because the graph looks professional. Okay. So now you can see it's kind of color coded. What if this was going to be printed in black and white instead of in color? You can change the design of your data series. You can format data series. If you go to the marker options. Okay, so go into this paint menu, paint thing. So what I did is I right-clicked on one of the data points in that and went to the paint menu here and marker options. And I can go to built-in and see how I can change the shape. So I can do I don't know, somebody pick one. Maybe the X's maybe? I don't know. I don't know, X might be a little, how about squares? Let's do that. That way if this came out in black and white, they'd say, oh yeah, the circle belongs to the first line and the square belongs to the second. And so I'm going to move my mouse over one of the data points right here, and I'm going to right click on it. And then go to format trend line, and then I'm going to go to this paint menu here. Actually, that's the trend line. Right clicking on it. And you gotta get, it's kind of hard, I gotta move my, I click on one of these data points, there you go. So you gotta maybe zoom in and then go to format data series, that's where you gotta go. Okay, go to format data series. to this, just make sure you're on the graph itself, and you would go to select data. And then you can pick either one of the so when you do that, one of yours will look like series, whatever, or mass. Yeah, there you go. So once you're in there, just pick on whichever one you want to change, and then go to edit. And then click on this box. And then click on the cell. So one last, or a couple of things I want to mention as well. We looked at the slope. Why is this even important? Like, why do we make graphs? Why do we make graphs?
Project data for people who don't want to read our lines.
To a certain extent, but there's more to it than that too. Numerical data in a table is fine, but if you can see it on a graph, it shows people trends, okay? And when you can see trends, it can be used to predict future things that happen. So a lot of people say, well, do you have a crystal ball? Well, no, but I can tell you what happens, in the past, and maybe use that trend to predict what might happen in the future. All right, so there's something I've been studying lately. I'll just share something with you. How many of you have ever heard of Elliott wave theory? Elliott wave theory. Have you ever heard of it? No. It's a way. Elliott wave theory. Okay. It's a method for stock market analysis. And so I've just been studying this. And there are certain rules to it, but the idea is that the stock market moves in waves, it moves in cycles. All right, the stock market just corrected by a lot, and that was somewhat predicted, okay, by this theory, okay, and stock market technical analysts use that theory to get out of the market when it looks like it might correct, and then get back in when the market looks like it's going to rally again. But they use graphs to predict this, so it's useful, okay? And science is all like this too. All right, I'll show you a copy of my thesis when we have a break here, but based on this data, what this says is that from around 0 to 25 milliliters, we see a linear relationship between mass and volume, at the very least. Okay. Now for density, you'll always see a linear relationship. A couple more things. What is it about this graph that I can do to make it look a little bit better? It's pretty good, but I'll tell you what I don't like is how this line forces this axis to go down. That bothers me. Alright, so I'm just going to go ahead and format the trend line again. Okay, and then forecast it backwards just a little bit, maybe 3 instead of 4. And now I got rid of that extra graph. You know what also, oh yeah, I guess it's okay. The legend kind of takes a lot of space too. I don't like that. I prefer to do this. Alright. Alright, one last thing I want to make about the graph. What does the R squared represent? It represents how well a linear function fits the data. So, of these two graphs, which one is more linear?
The wood.
The blue one is more linear because it's closer to 1. Alright, the closer to 1 the r squared is, the more linear the fit matches the data. Okay? So if I was going to hire somebody to measure densities of solutions for me, okay, which student do you think I would hire? The one with the blue. Okay. I just used real data to hire somebody. All right, that happens. They look at quality of your work, and although the other person's pretty good, they're pretty close. All right. All right. Shall we take a little break?
Yeah, please.
All right. Let's take 5 to 10 minute break, and then we'll come back.
I'm hungry again.
Oh,